Okay, so this is the data that we have. The selling price is 210 per unit, and the manufacturing cost is 135 per unit. This is the demand function. To get the profit function, we have to consider the number of units times the price per unit less the cost, less the total money spent on promotion and development. It's what the problem says. And so we are going to have this profit function, and now we're going to get the first derivative. Okay. In order to get the first derivative, we are only going to take into account the terms that have an x. And we're going to use the division rule, which is this one. And so when you compute it, you get this result. And to get the derivative of y, we're only going to use the terms that have y, which are these ones. And so, again, we use the division rule, and we get this result.
Now that we have equaled it to 0, we are going to clear the variable x in this case. So very simple, we just pass the 1000 over here. Very simple, clearing the variable. And we got an x equal to 4. Now, with the y, we equaled it to 0, and we cleared the variable y.
Now, to get the second derivative, we have to use again the division rule, and so you cancel this term because it multiplies by 0, and like you have an x plus 5, you can cancel it with one of this, and so you're going to get this result. And in order to get the second derivative of y, it's pretty similar. You cancel this and one of this, and so you get this result. And to get the fxy, it's just 0 because the first derivative of x has no y.
And now we evaluate the critical points. Remember that it was 4 and 9. So 4 and 9, we just did this equation, just solving an equation, and we got this, right? And since it's greater than 0, we are going to have to evaluate the critical points in this equation right here.
And so we just evaluate on the second derivative of x, and since the result is also positive, it means there's a maximum point at 4,9, and so this means that the manufacturer, in order to get the maximum profit, should spend $40,000 on development and $9,000 on promotion. In summarize, this is what we did. First of all, we got the profit function with the data that the problem gave us. Then we derivated in relation to x and y and got the critical points. Then we equal them to 0. Then we got the second derivatives in order to put them in d. Then we had to evaluate d and the second derivative of x, and since both of them were positive, it was the maximum point.